guys, this is Outstanding Chem Academy. If you are a new subscriber here, you are welcome to my channel. And for the existing subscriber, thank you for staying tuned to this channel. Okay, my name is Lady Kazum, your host on this channel. Please do me a favor by clicking that share button, click like, and please click notification button so that new updates videos that will be coming up, you'll be the first to be notified. Thank you. Kindly use the comment section. It's very important to us. Thank you. Today we'll be looking at an important topic in chemistry. All right, let's play that. All right, the topic is oxidation number. Oxidation what? Number. Well, by definition, oxidation number of an element in any particular molecule or ion is defined as the electrical charge. Electrical charge that it appear to have as determined by a set of arbitrary rules. There are rules that govern the determination of oxidation number, and I will be giving you such rules. After this, I believe there will be no issue, there will be no problem determining the oxidation state of any element or in a compound or in a radical. Quickly, what are the rules? Rule number one states the oxidation number of a monoatomic ion is equal to the sign of its ionic charge. For instance, bromide ion has -1, sodium ion +1, calcium +2, oxygen ion -2, aluminum ion +3, and nitrogen ion -3. For number two rules, the oxidation number of an hydrogen in a compound is always +1 except in metal hydride. For instance, you have NaH, the oxidation state of hydrogen in the compound is -1. Did you get it? Number three, the oxidation number of oxygen in a compound is always -2 except in peroxide like H2, O2, Na2, O2. These are peroxide, all right, where it is -1. Rule number four, the oxidation number of uncombined elements is 0. For instance, N2, the oxidation number or state is equal to 0. O2, the oxidation state is 0 because it's an uncombined element. Sodium, aluminum, they are equal to 0. Rule number five, for any neutral compound, the sum of the oxidation number of the atom in the compound must equal to 0. Must equal to 0. All right? Did you get that? Number six, this is the last rule. For radical, the sum of the oxidation number must equal to the ionic charge on the ion. Like CO3 2 minus equals to -2, NO3 equals to -1, and SO3 2 minus equals to -2. Now, let's the oxidation number. Let's look at example 1. Example 1. Let's determine the oxidation number of the following underlying element. Underlying element. An element underlying if it's in a compound or in a radical. You just want to determine the oxidation state by making use of the set arbitrary rules. Example 1, let's look at it. Example number 1, we have CaCO3. The underlying element in CaCO3 is what? Is carbon. What is the oxidation state of carbon in this compound? Let's calculate together quickly. Let's see the method we are going to use. CaCO3 equals to 0. Let me summarize it. All these 6 rules are basically on this basic rule. Number 1, if you have a compound, a neutral compound, okay, and any neutral element, the oxidation state is equals to 0. Did you get that? Number 2, in summary, if you have a radical is a group of atoms that have both positive and negative ions, or you have a cation or anion, the sum of this oxidation number or state is raised to that power, the power assigned to that radical or a cation or an anion. Did you get that? So this is a neutral compound. So automatically it will be equals to what? 0. So let's look at it. So we have Ca plus carbon plus 3 atoms of oxygen equals to 0. All right. What is the oxidation state of calcium? Remember, calcium is 20, periodic table, look at it, 2882. This is KLM and share. The maximum number here is 8882, but we have 2. So it's going to donate this electron. If it's donating is plus. So you're going to have plus 2 plus carbon plus 3 atoms of oxygen. What's going to be for oxygen? Oxygen is 8, that's 2, 6. Remember, this is K share, this is L share. The maximum number is 2, maximum number is 8. So we have 2 electron lacking. So we are going to have minus 2 to make it up to 8. That's how we arrive at that. If you want me to do a topic on that, please leave a comment in that comment section below so that I'll do a topic on periodic table. Okay, let's really conclude this calculation. So we have plus 2 plus carbon minus 6 equals to 0. Collect the like time. C plus 2 minus 6 equals to 0. So we have C minus 4 equals to 0. C equals to plus 4. Did you get that? So the oxidation state of carbon in CaCO3 is what? Is plus 4. Can you see that? Is plus 4. It's another topic because we can use this one to determine the IUPAC nomenclature of CaCO3. If you want me to do a video on IUPAC nomenclature, you can tell me that in comment section below. Thank you. Let's really go to example number 2. Example number 2. Quickly, as no time. Look at example number 2. Example 2 is MnO4 minus. The underlying element here is manganese. Remember, what our rule says is a radical. So the sum total of all the elements in here will be equals to the power assigned, which is minus 1. You're going to have Mn, okay, plus 4 atoms. Oxygen is equals to minus 1. Are we getting it? All right. So Mn minus or plus 4 minus 2, remember, minus 1. Remember, I just determined the oxidation state of oxygen. So Mn minus 8 equals to minus 1. Collect the like times. Mn equals to minus 1 plus 8. Mn equals to plus 7. The oxidation state of manganese in this compound equals to 7. Did you get it? We are making progress, right? Quickly. Let's go to example 3. Quickly. No time to waste. Example 3. Example 3. Let's look at that. Example 3. Okay, check it out. We have Cl2O72 minus. Determine the oxidation state of chromium in this compound. Let's determine the oxidation state of chromium in this compound. All right. Good. That's 2 chromium plus 7 atoms of oxygen is equals to minus 2. Remember our rules that says when you have a radical, it's going to be us to the power. Quickly, let's look at it. So 2 chromium plus, what's the value of oxygen is minus 2. Let me remind you, oxygen is 8, 2, 6. That's the atomic share K. The maximum number is 8. All right, so we have 2 left. So we have 7 multiplied by minus 2 equals to minus 2. So we have 2Cr minus 14 equals to minus 2. So 2Cr equals to minus 2 over there, 14. 2Cr is equals to plus 12. Divide both sides by 2, you have your final answer to be what? Plus 6. So the oxidation state of chromium in this particular radical is plus 6. You know, the sign is very, very important when it comes to calculating the oxidation uh, number. So let's proceed to example 4. Hope we are getting it together. Example number 4. Quickly. Example number 4. Let's look at example 4. NH4 plus. All right. Let's have this. We are looking for nitrogen. All right. Equals to plus 1. So look at it. Nitrogen plus 4, hydrogen equals to plus 1. The state of hydrogen is plus 1. Hydrogen is equals to plus 1. So I have N plus 4 plus 1 equals to plus 1. Did you get that? N plus 4 equals to plus 1. Collect the like times. Your N equals to plus 1 minus 4. N equals to what? Minus 3. That's the percentage of nitrogen in ammonium. All right. Example number 5. Quickly. Example number 5. Hope you are getting it. If you have any question, use the comment section below. We'll get back to you. All right. Look at number 5. Let's look at N2S2O7. What is the name of this? What is the oxidation state of S in this particular compound? So, of course, you have 2 Na, right? Plus 2S plus 7 oxygen equals to 0. The rule says so. It's a neutral compound. There's no ion in it. So now how do we remember the oxidation state of sodium? Sodium is 11 on the periodic table. That's 2, 8, 1. You can see this is KMN 2, 8, 8. So the number here is what? Is 1. It's going to donate this as plus 1. That's 2 bracket plus 1 plus 2s plus 7. By now, you should know that oxygen is minus 2. So open the bracket, you have plus 2 plus 2s minus 14 equals to 0. Do you get that? Collect the like times, you have 2s plus 2 minus 14 equals to 0. Then what do you have? 2s minus 12 equals to 0. So 2s is equals to plus 12. Divide both sides by 2. Your final answer become plus 6. Did you get that? Are you following? Plus 6. Okay. In conclusion, let's look at two more examples and we are out of this place. Good. Let's look at this. Example 6. Example 6. Quickly, example 6. What is the oxidation state of magnesium? Let's look at magnesium, for instance. Magnesium. What is the oxidation state of magnesium? It's underlined. The oxidation state is equals to what? 0. That's the rule. Is a neutral what? Atom. Neutral compound, neutral atom. Oxidation state is equals to what? Is equals to 0. We are done with that. Lastly, number 7. Whoa. Let's look at this compound. This compound. What is the oxidation state of oxygen? It's looking very strange, right? Which one is coming inside bracket again? Okay, let's look at it. So we have Al plus this reaction is telling us we have oxygen, hydroxide, in 3 places. So I'm going to have 3 atoms of oxygen plus 3 hydrogen, everything equals to 0. Or you can multiply it 3 times 0, 3 times 1, 3, 3 times 1, 3. Okay, we remember that aluminium plus 3, oxygen is minus 2, plus 3, hydrogen is plus 1 equals to 0. Open up the bracket, you have Al plus Al minus 6 plus 3 equals to 0. All right. Correctly like times, you have AL minus 3 equals to 0. AL equals to plus 3. Did you get that? Very exciting. Okay, thank you for staying tuned to the end of this video. If you find this video very interesting, okay, share it, tell a friend, okay, invite your friend to come and subscribe, and click the notification button. Thank you for watching this video. See you next time. Bye.